Okay. Okay, everybody, thank you for your patience with our experiment here in cyberspace. So thank you all for coming. I'm Stu Lipoff. I think I met you all before the night is over. We're a small enough group that we're going to get to know everybody, so not a problem. I have about a 15-minute or so intro, and I'm going to ask our host also to come up during this intro to just say a little bit about who they are and what they do here at the university. And I just want to say before I get to a slide that says that, I want to say how much I appreciate the UNLV folks making all this available. For those of you who haven't figured it out, this is kind of a joint effort between the IEEE student chapter here at UNLV and the Consumer Technology Society, which is organized like all big bureaucratic organizations under a completely different framework than the student chapter in the Las Vegas section. We're part of the Technical Activities Board. And so we are a society that relates to a particular technology area, in this case, consumer electronics, consumer technology. And we host a bunch of conferences which are international in nature, not necessarily geographic. This is the first year in about 35 years we have not had our big 3-day conference here in Las Vegas. This is probably a better event because I think we have a higher quality audience, and I think you're going to find the discussion with the speakers really be interesting. So you figured out we're past the pizza part. I'm going to do about 15 minutes of just welcome and introductions, and we'll actually get into the substance of this with our distinguished panel members here at 7 o'clock. I should mention that I have been involved working with Michael Condrey, who is the event chair, in actually organizing the local arrangements and logistics. Michael has done all the hard work in terms of recruiting the panel. And I think it's time for maybe him to say just a few words about an event he's planning for next year. We were hoping to do it this year, but it was something called the WTS. Michael, do you want to mention something now about that, or you want me to just read the slide? Okay, he'll do it when he gets to it. But any event, we are planning next year to do a World Technology Summit, which will actually be located at CES, done in cooperation with CTA, and that's planning on being a full day event, largely covering, I think, much of the same subject matter that we're dealing with here, which is basically an executive panels where we actually our audience and the subjects are technical matters, not industry or marketing matters, and dealing with how those interact with the different businesses and opportunities. I do want to thank our hosts, though. We actually have a benefit here of 4 people who really helped us put this together. We have Dr. Brendan Morris, who's professor of engineering, computer science here in the UNLV College of Engineering. We have Michael Genova, who is a professor in the entertainment engineering and design, which is part of the College of Fine Arts. We have our IEEE student chapter chair, nominally our host. And I don't think she's here yet, but we have Tracy here, who's just done an incredible amount of back-end work in terms of supporting us with the web and a bunch of other cyber support activities. Brendan, you want to just say a few words and introduce yourself?
Well, thank you very much. I appreciate it. Yeah, I'm Brendan Morris, and I'm a professor here in electrical and computer engineering at the Howard R. Hughes College of Engineering, and it's my pleasure to have all of our distinguished speakers. Thank you very much, as well as all of our audience. We really appreciate you being here, and we hope you have a good time. I am also the chair, or not the chair, the mentor for the IEEE Student Branch here, and so this is something that we are very pleased to be able to put on and have folks from industry come here. You may know UNLV, or you may know Las Vegas, I should say. You may not know UNLV, excuse me. But we are a university here with actually a pretty large one. We have about 30,000 students, and engineering is one of the larger colleges. We have electrical engineering, computer engineering, computer science, mechanical engineering, and civil engineering. So yes, we do have engineering going on here. We don't have a whole lot of job opportunities for electrical engineers locally. So certainly from those that are coming from California and other places, we would love to have you come visit us and help us recruit some students. And with that, thank you very much. I hope you guys enjoy the program.
Thank you, Brendan. Next up, our other host is Michael Genova.
Hello, everybody. Welcome to UNLV. My name is Michael Genova. I'm the Director of Entertainment Engineering and Design here. For those that are unfamiliar with that, it is an interdisciplinary program between the College of Fine Arts and the College of Engineering. Been around, I still call it a fledgling program. We've been around since 2008 with our first cohort graduating in 2012. Program's growing rapidly with 2 years of 25% growth, and next year we're anticipating a 35% growth. In the program, student headcount, a lot of that is attributed to the fact that last year we just received our ABET accreditation, so it is a legit engineering program. Stu, I don't want to advance the next slide. Anybody's interested in learning more about the program, there's a QR code for you. I will also be available during this, after this presentation to talk to you a little bit more about it. Thank you and welcome.
Unlike the many people here, my relationship with UNLV is not as a student, but I was recruited into the College of Fine Arts Advocacy Board for the Dean because of this entertainment engineering and design. I think it's just an incredible program because it's at the intersection of technology and fine arts, and you know, building that bridge between the people who are incredibly creative as well as the people who know how to do the technology to make it creative is serving a really important need, especially as you know, the stuff that happens on the stage in the movies and games and everything else now is just so technology rich. So I think to me this is a really exciting part of the university. I'm hoping that it's going to be something that actually grows to diversify the local economy here. So that's the end of my commercial. But thank you, Michael. My finger was pretty fast here. I didn't mean to, but I skipped over. Do you want to say something about the student chapter? I pushed the button one step too far.
Hello, my name is Nitya. I am the president of the IEEE UNLV IEEE Student Chapter here, and I'm a senior in computer engineering right now. I'll be graduating this semester, and I do want to go to grad school, and I want to research in biomedical engineering, and specifically in like digital health or like medical devices. And so with the IEEE Student Chapter, I want to just continue organizing workshops for students and organizing these collaborations with such as this one with the Consumer Tech Society. And I'm so grateful that you guys can make it here today. And yeah, hope you guys enjoy tonight. And
Thank you. And I was when I was looking at the registrations for this, the very first person who registered, I looked her up. I found out she was the past IEEE student chair sitting in the back there, Katie. Hello, Katie. So we have two decades of leadership here, of 2 generations of leadership here in terms of IEEE at UNLV. So I think you guys are all aware, the panel members, we have very senior executives here, and we did, in what we published on the website, we have their LinkedIn page, so you can look a little bit more at them here. But as you can see from the titles, that these are folks who are heavily involved in various different parts of the industry. The focus of this is AI, but many of the panel members here are deep into some aspects of wellness and health and medical. So the panel is obviously going to drift into that direction. I'm a communications engineer, so I don't know anything about this stuff, but I'll try and do a good job as moderating. I have 2 slides before we actually jump into the substance of this and the panel starts talking. What I found is that my experience in this industry and what I've been following in terms of papers, presentations, other things in our society, the AI apps that have kind of surfaced so far in terms of actually being commercialized tend to fall into these categories: generating content, driving vehicles, enabling chatbots and lookup, natural language understanding, and getting into making recommendations. We're beginning to see some very substantial use of this technology in a way that we never had the ability before, which is to take huge databases of both public and private information that relates to you and other people and quickly go through it, analyze it, summarize it, and everything else. But so far, I think this is kind of sleepy stuff, because what everybody, I think, is looking forward to is sometime in the future, looking forward to with both hope and dread, depending on where you sit, to go beyond actually analysis, to have AI make some recommendations, but then actually not just recommending, but actually acting on them by having the agents talk to the people to do things, direct them to do things, or talk to other agents, which end up doing it. And the whole theme of some of the sessions I've been attending here at CES were about networks of agents and agents, or giving it a couple different names. But I think people do see this future where we're going to move beyond analysis and recommendations. So I thought it was kind of curious. AI is also the initials for all in, and there's hardly anything you can bump into on the floor of the CES where you don't see this. The topic of this particular panel is opportunities and challenges for AI integration into consumer electronics devices, consumer technology, services that are on the web, and everything else. And as we hear from each of the panel members when they make an opening statement and then get into some Q&A, I think we're going to find the opportunities are going to fall in the general categories of improving the performance, making better decisions, more convenient, not just ease of use, but learning how to use things, which very complicated capabilities you can put into the software, but teaching people how to actually get the value out of it by having something friendly on the front end that allows them to configure it and control it, as well as a whole bunch of new features and stuff that don't exist yet. But the challenges, I think, are a longer list, and I would expect during some of the discussion we're going to have here, there was going to be perhaps an imbalance, just my guess, in terms of talking about it. Technologies historically in applying this technology goes back academically to the mid-40s or so, but it really hasn't found its way in the commercialization because we haven't had processors which had the right architecture, which were fast enough, had enough memory, cheap enough, and developed some of the algorithms. And there still are perhaps technology limitations going forward, especially issues associated with thermal management in the back end and stuff like that. Social acceptance is always a big part. The extent that you're going to have your physician or your accountant or your stockbroker turn over some of these capabilities to a machine is another issue. Hostile gatekeepers is on my category. People who don't want it to happen, either afraid to happen or whatever, and are positioned to do something. Government regulation, which can sometimes help and usually doesn't. Lack of standards. Infrastructure, do we have enough connectivity, enough back-end processing power, intellectual property rights? Fear of litigation, especially on the medical side. The issues associated with having some machine make some sort of decisions that later on people are going to find an attorney, especially here in this town. You can't drive a block without finding a billboard that doesn't have a limitation. So here are our panel members. I think Michael wants to start, and I'm turning it over to you.
Okay, thank you. Let's see if I can flip the control. Next slide. No, we need to close this. And we need to find my talk. Now, the question is, does it work? If we got to switch again.
Presentation mode. Yeah, there you go.
Okay, okay, it's not moving for me. Okay. So I'm going to start this off with a bit of a challenge. I've asked all the speakers to focus not just on general consumer technology, but particularly looking at the healthcare industry and smart healthcare. And I'll explain why at the end of this as we propose an event we're trying to get together for CES 2027. So with that in mind, I will push the button here. So I'm cutting to the chase by looking at presenting to the group here a challenge to consider as opposed to any other history. If I look at a lot of consumer product strategies, we basically have three components that are the main drivers, particularly in the AI space. There's a client device like my watch, or something you wear in your head, or something you put on and you measure your test. And it's usually a low cost, relatively low cost, at least the objective, if you want to get a large market, is you have to have a large cost. And then you need something to get things together before the AI engine. Maybe it does some AI itself. And that's often done at the edge, which is quite typically, this kind of device that has enough computation power to do encryption and identification and all that stuff, and good, strong communication. And then most of the AI is too complicated for just that device. It has to go out, and that's where the cloud comes in. And I've seen several applications that kind of fall into this model. You use the fact that everybody's got a smartphone, so you don't need to have that computation at the very end. And you use the very end to keep the costs down so that people will buy more of them. And then you use the cloud for where you need the high-powered engine. Anyway, the challenge is, how do you break it up? You got a problem. How do you partition it between the three sources? What goes out in the edge? What do you do? What goes out the end dice? What do you do at the edge? And what can you do out in the world? And there may be different ways of looking at this. So I just thought about bringing a challenge here, not a solution. Is it, everybody's talking about LLMs like ChatGPT, which Stu brought up as one example. But at ASML, we found out last year when we did a WTS on AI infrastructure, they've created an LLM model that basically evaluates circuits and see whether the circuit is going to work correctly, which is kind of interesting. And they're actually using that in their business. We have some in autonomous driving, such as the LLM service. So the question I'm bringing up, I don't have an answer. I'm bringing the question as a challenge. So we have some medical application or some smart consumer application, and we want to break it up. We want to keep the sensors or the end device pretty much just very simple processor and communication, but mostly sensors. It gets the basic information. It's not going to be a super power box. The edge device, which is usually a smartphone, can be another. It does some of the AI processing, but it would do things like encryption and so on. And we have the cloud. So what's the best way to do it? Can we build an LLM model that'll actually say, this is the way to partition it, or your partition is correct, or it's done as the AMSL thing? We have to analyze the data, how it flows, what computation is needed, but these things can be specified as sort of a language. So, whoops, I think I went the wrong way, guys. Okay. So that's the challenge I wanted to bring out. But the most important thing I want to think is we're really trying to have not a mini event like this, but a full-size event at CES next year. And this is going to take place all about smart health devices, the ecosystem for those devices, the components, and the applications, like applications to get your symptoms. There was a gentleman in Japan who has a device that with multiple sensors can actually do a CBC, a complete blood count without piercing the skin. And you have various health devices coming out, how many steps I walk, blah, blah, blah. And there's two sides of this. One is the immediate measurement, and one is looking at measurements over time, which is where the big AI engine may come in, because that's how you sometimes find change that you don't expect. We have the components involved, we have the infrastructure needed, and of course, in the medical or even the consumer medical, we have regulations, security as major issues. So all of these are going to be areas that we're going to work with companies, find out what their issues are, and bring our speakers out to do that. So that's my quick introduction. And I'm going to turn it over to Michael, who is going to be giving us Samsung's perspective. Michael, do you have slides in here? Okay, well, let's just do it like this.
Great. Thank you very much, Michael. I think there's several Michaels and Miguel, so should be easy to remember. So I do not have slides, sorry about that. But what I can do is I can share a little bit about my perspective from my own background, as well as what Samsung's approach is to this. So my name is Mike Friedman. I'm a physician. I'm a practicing physician and faculty at Stanford in pediatric critical care medicine. And this gives me an interesting perspective for my other job, which is my primary job at Samsung, looking at different emerging technologies. I lead emerging technologies within the digital health team. So I think of it, in the ICU, you have a massive breadth of disease, and you have a massive array of sensing that you can use on the human body. And then in Samsung and consumer wearables, you have a very reduced space that you want to be able to have sensors on in a consumer wearable device, and you have a much narrower scope of disease. So you're not looking at sepsis or severely sick patients. You're looking at a lot more of these disease states that are much more common. So within my role at Samsung, I look at trying to piece together early stage R&D collaborations to help drive the cutting edge and innovation for the earliest parts of the pipeline. So bringing in new sensors, new algorithms, new AI to be able to power all of our devices. And that brings me to Samsung's thesis. Actually, before I go into that, I'm at SRA, which is Samsung Research America, based in Mountain View, which is the R&D engine that drives the commercial group forward. So we look at trying to find the next best thing to be able to further mature it, further develop it, and then to be able to commercialize it. So at Samsung, we are, as you know, a huge consumer electronics company. 70% of American households have at least one Samsung device in them. We have lots of smartphones, we have watches, we have rings. All these have lots of embedded sensors. And with that, we want to be able to try to measure and help people with their health from the full spectrum and journey of healthcare, from screening asymptomatic people to helping to diagnose disease, to help manage chronic disease, help interface with the healthcare system if we can, and then help with post follow-up and discharge. And ideally, we would want this to be in a proactive manner. A lot of what we have in digital health right now is very passive and reactive. You wait and see, wait till something happens, and you say, hey, I need to tell you, you should go do this because something is happening. Wouldn't it be great if you could actually prompt someone in advance to say, I think that you may be at risk for something, you should be able to do this, or before it happens rather than reactive. So with that, I also want to mention that Samsung made an acquisition this past year for a company called Zelf. And what Zelf is a digital marketplace for digital solutions and digital therapeutics it's embedded in health systems across the country. And this is a big step for what we want to be able to do in advancing the field of digital health and consumer electronics forward. We know that there's a lot of forces here that are bringing healthcare outside of the hospital, outside of the doctors, but more into the home and into the hands of users and patients themselves. So with this is a way, a vertex for people to be able to get their care in the home that is directly matrixed through the hospital system, and Samsung would be embedded in the middle of that. So I'd also like to say that we are a company that loves to partner because we cannot do it alone. We have a huge ecosystem. Really, our business model is predicated on it. We have smart things that is a mesh network of things within your house, both within Samsung devices and other devices that can not just be a central hub to be able to access and control your home, but also can pass data, and you can derive health metrics from this too. And we also look at external collaborations with startups and labs, trying to look at the really cutting edge sensors and technologies to try to work and co-develop with our partners. Because as I mentioned, we're in Mountain View and we're in the heart of Silicon Valley. We like to be able to co-innovate, and that goes beyond Silicon Valley as well. But in the United States, generally speaking, we want to be able to form partnerships in research that so that we can be greater than the sum of our parts. So the best of academia, the best of Samsung coming together to really accelerate the R&D process. And then finally, we have a really rich open access toolkit for a lot of researchers, and I think this might be really relevant for this audience. We have several SDKs that can, for consumer electronic wearables, it's kind of rare to have something that you can actually have full raw access to all of the raw data. So we have that with our sensor SDK from all of our Galaxy watches, all of the sensor modalities that you would be interested in. And we have also all the derived metrics as well through Samsung Health and of course through the Ring. And we have lots of other things coming down the pipeline. So with that, it's a really exciting space. I haven't really commented much on AI so far. So AI is really driving monumental changes in our landscape. We have seen some massive changes even in the past few days from commercial launches that have been announced here at CES, as well as in the regulatory environment. I'm sure we'll talk about a lot about that more in the panel discussion. But needless to say, these are reflective of empowering patients and users with their data much more liberally than they have in the past. And we're seeing a lot of evidence for that. So with that, I welcome further discussion and thanks for having me. And now I will hand it off to Miguel.
I'll remain seated if that's okay. I don't have slides either, but thank you all for joining. Thanks for the opportunity, Michael, to be here. Pleasure to be at UNLV. My name is Miguel Adao. I run a company called Volair Systems. And Volair Systems has been based in Sunnyvale, not far from Mountain View in the Bay Area, for 46 years. Our founder started the company in 1979. He hired me 3 years ago to help him exit the company, and we're excited to be able to announce at CES that we will be selling the company to a Canadian company, a French-Canadian organization this month. So we do medical devices, wearables, and IoT device and design, purely hardware and firmware, sensors, power management, wireless. 80% is medical devices, classes 1, 2, 3. Under the FDA regulations, a lot of neuro, a lot of cardio. And I was thinking about what to say here in the introduction. Maybe I'll take a little bit of a contrarian. It's always good to have a controversial point of view. Otherwise, you can't have 5 people agreeing in the panel. I still am not convinced in my world of physical development of devices and the power of AI. I'm still very much on the fence. I think it's a lot of smoke and mirrors. When you are vibe coding for an app to find you a nice hotel, that's fine. But when you're dealing with somebody's pacemaker or neural implants, that could kill someone. So we're still not seeing at this stage, and I agree with Mike, there's a lot of interesting technology. CES this year is definitely turning the corner in many respects. But at this stage, in hardware and firmware specific, for medical devices, medical wearables, we're still not quite there. It's true what Stuart said. AI so far has been good at analyzing and diagnosing certain aspects of information or data. In our world, the best beachhead and beacon of hope has been in the imaging side, where AI is now identifying, say, cancerous tissue in a breast X-ray or in an ultrasound better than humans. And so that's very encouraging. But in terms of changing AI from diagnosing or analyzing data to actually taking action, we see it. Some of us have cars that will take over the steering wheel or perhaps put on the brakes if we're getting to a dangerous situation. And so that's the beginning. But in the medical side, we're not yet seeing it in our device development. Another thing I'd like to say is that it's very interesting when you think about, and perhaps many of you are too young to remember, but IBM Watson, it's been 25 years they were talking about AI. Steven Spielberg made a movie about it 40 years, 35 years ago. But IBM got rid of their AI division at the time. And what we're seeing is we're right in the epicenter of Silicon Valley where a lot of the innovation is being developed. It's the startups, it's the solopreneurs, entrepreneurs that are really driving innovation. And then the large intuitives, Medtronics, J&Js, and Abbotts are snapping that up, which is probably the best way to approach it. Another dynamic that we're encountering in our world is that the FDA does not understand AI at all. And so we're having to educate, we in the industry, we're having to educate the FDA. There's a big battle right now between what's a wellness product and what's a medical product. So if you wear an Oura ring or some sort of wearable to tell you the quality of your deep sleep, that's fine, that's a wellness. But once you start going into blood pressure, oxygen, heart rate, and other diagnose if you're gonna have Alzheimer's one day, you cannot just sell that off the shelf. You have to go through a regulatory process. And there are companies out there pushing the envelope. Whoop has been the one that has been more prevalent in the news if you've been following. And so there's an interesting battle and an interesting convergence of points of view between large and small companies. The small companies are leading and then being acquired. An interesting dynamic between the FDA, the mathematicians and the academics, and the practitioners. And so we're seeing that as well. In many respects, I feel, I spoke about vibe coding. I feel that very often we get a device or a prototype or proof of concept from an organization where a lot of the AI was already developed for the software side, for the app, for the cloud. And many of these devices, physical wearables, physical devices, physical equipment, could be as small as a ring, it could be as large as a surgical robot. We struggle to adapt the AI-led software and firmware. Firmware is defined as embedded software that goes inside the device. And very often we're finding we're going to have to start from scratch. So for us in the physical hardware side, we're struggling to adapt AI native software apps and development. And so it's a very interesting time. It feels akin to 1997 as the dot-com era is starting. Some of you are too young to remember Webvan and Pets.com and Peapod. Peapod would send you a Snickers bar to your house. It would never survive. Now Amazon can actually do it because they got the infrastructure for it. But it was an interesting time. I believe that a lot of the names that we hear about today will not be around in 5 years. And so on the physical side, especially on the medical physical side, we're taking a conservative approach because it's a lot of it is hype. But it's an exciting time, and yeah, appreciate the opportunity to be here. My last name matches yours. Adao in Portuguese is Adam, so
Adam.
I'll give you the mic.
Thank you. Okay. So I have two ways of,
Do you have some slides?
yes, but I have two ways of doing this, with slides or without slides. And maybe I will do it with slides, okay? And I think from what you've heard so far, maybe from a somewhat different point of view, sort of very high level on one end, okay?
Yours.
That one.
That one, okay.
Okay.
So we have a little game to play here.
And then go into slideshow.
No, we need to switch. Come over here. Nope.
Okay.
You're on.
All right.
Is it up there? Okay, and how do I advance it?
Oh, you have to do it up here. You have to move the mouse.
You could use this.
No, that doesn't work.
Doesn't?
Just use the mouse and take it up.
Which mouse?
No, I'll show you.
Whatever
So I'm ahead of you on this one.
Oh, okay, I see. I got it.
You
I
got
got it. Okay,
You're in.
thank you. Okay, so let me start off with the following. I thought I would start off with a high-level view in terms of looking at healthcare products and services, what that means, and maybe drill down on some very specific things. And I would say as an introduction, let me start off with two statements. You know, the first one is something called Amara's Law. I don't know how many of you have come across that, but bluntly what it says is the following. We tend to overestimate where technology is in the short run and really underestimate where it'll be in the long run, okay? And to some extent, I would echo Miguel's feeling that we have gotten a little bit ahead of ourselves. There are a few things that work, but they don't work well enough for a lot of what we're dealing with in healthcare, okay? And the question is, how do we get on the journey from here to there so we eventually actually reap the benefits of what this technology can mean in the long run, okay? So that's one. The second thing is, this is done in a human setting, okay? And I would go back to Machiavelli, who also had a very interesting quote. And he says, there is no more dangerous thing to do than to change the order of things, okay? Because there are institutions around, they have standing, they have a say in things. They tend to be conservative for a lot of reasons. They tend to be very jealous of the power that they hold, okay? And sometimes I would say getting technology adopted, used, okay, is overcoming those human feelings, okay? So I think with that as a preface, let me say I'm gonna hit four things. Little bit of setting the stage. I think a focus on data and computing because they have a fundamental impact. The next one is sort of security, cybersecurity, privacy, and assurance. It's sort of a bundle, okay? It deals with a lot of legislative, regulatory things that are out there and a lot of real problems, and then be open for questions and answers when we're done with that, okay? So let me take a look at the first one of these, which is setting the stage. And, you know, I don't know how many of you appreciate this, but if you look at the US economy to begin with, which is somewhere north of $30 trillion, roughly 18 to 19% of that is attributed to healthcare. Yes.
Can I interrupt you for a second? Our remote viewers would like to see the slides. I'm gonna-
Okay.
Can I interrupt you just?
You can certainly interrupt me, okay? Okay.
Pardon me, everybody.
So you have to do a share.
Should have figured out how.
You should have set up the share to begin with. Yep. Okay.
Larger, right?
No, you don't have to make it larger. You just have to do the share. Yeah, do the more, hit more. On the bottom.
Yeah, I'm looking for share.
No, hit more.
Or, okay. I know how to do this at home really nicely, but.
That should allow you to
Yeah,
do.
share.
Share, correct.
Okay.
Click share. And then click on the slides, which are down here in the middle.
This one right here?
Yep, click on that.
Those are your slides? Okay.
Okay, you're now sharing.
Okay.
Okay.
Let's go back to your.
No, no, that's fine. Okay, everything is fine.
Well, we don't have it on screen, so we want to get.
Ah. Okay, hit this, hit this.
Yeah, I'm doing it.
Okay, how are we doing?
And one more thing. Duplicate slideshow. I think that'll do it, yeah?
Okay,
No, but we're almost there.
click that again. Okay,
I think we're largely there, yeah?
okay, okay. Okay. No, don't worry about that. I think if you try moving that, you'll end up with a problem. Okay, anyway, so as I was saying, when you look at healthcare, it's attributed to be roughly that 18 to 19% of GDP. It's a huge number. And it's also very complex because it has many dimensions to it. It's the practice of medicine. It's the practice of well-being. It's environmental issues and exposures, and it's managing our own lifestyles, okay? There's a lot more to it, so I'm trying to be very simplistic. But when you actually add all of these up, what you find is it actually represents roughly a quarter of our GDP, okay? It's not just healthcare. When you look at the automotive space, 40,000 deaths a year, we talk about that. There is probably between 300 and 350,000 people who are hurt each year for whom you have to look after for the rest of their life, okay? It's an incredible burden. So when you start looking at AI and its contributions, okay, it contributes to health in many, many different ways, okay? That example I gave of the automotive world, just trying to cut that burden down by a factor of 2, okay? Because a human being at the wheel, okay, is probably the most dangerous thing that there is, okay? We have devices, for example, that can tell, smell on your breath, are you drunk, are you not, okay? Are you falling asleep? To get the legislation passed, for that to be accepted, and the devices which already exist, okay, is like climbing a mountain, essentially, okay? I see a few people agreeing. I'm sure this is, there's a controversial side to it. But in the end, all of this, says you really want to have evidence-based outcomes in what you do. You have to contend with disparate and complex sources of data. You find each of the boxes that I drew here has different regulatory and legislative agencies that deal with it, associations that deal with the things that they do. They compete with each other. People go influence shopping, things of that sort. Is it well-being or is it practice of medicine? I think that example came out before. And you can think of, I would say examples. We have a tremendous amount of advancement in genetics, okay? A lot of the analysis of that is already AI-based, okay? I can tell you sort of the story of 23andMe, okay, and their journey through the FDA, which did not have a good outcome, essentially, okay? So there is a lot that goes on in that regard. But what I want you to sort of take away from this is you have to, besides dealing with the technology, you're dealing with individuals, communities, and populations. I think of the pandemic that we went through. It's one thing to treat the individual who may have COVID. It's another to understand how is it raging through a community, okay? And the next thing is, how does it affect the whole population at an economic level and things of that sort, okay? So besides the enormity of this in economic terms, think of the complexity of this in terms of sort of human terms and everything that's involved in even moving the needle a little bit at a time, okay? And I'd say, Miguel, you've probably been, how would I put it, frustrated at times that you couldn't do certain things, okay? I would say it's because of this kind of complexity that exists, essentially, okay? Okay, so all of a sudden I lost how I do my advances. Okay, so next thing is data and computing. So I have two things. I have products and services. I have what I would call sort of the physical things from which we make devices, sensors, actuator, the computing electronics, the software, human interfaces. Very important, the swap, size, weight, and power. Can I actually miniaturize it, putting together? But is it reliable enough? Will it last long enough? Do I have, is it maintainable? Thousands and thousands of requirements that go along with this. Sometimes we think it's so simple to do. By the time you get into the guts of it, you find that having large organizations that have the skill sets that can do stuff at scale, that can sort of, in some systematic way, sort of climb the mountain of what it takes to bring each thing to market, all of that matters, okay? And then there is the infrastructure that goes along with it. And those are hierarchies, one for connectivity, data processing, for computing, and that is stuff that's local. You know, I look at communications within a hospital. I look at a body network on a patient. I look at stuff that has to go back to a data center somewhere, okay? That's true of my data. That's true of the computing that I have to do, okay? And then there is that soft world of rules, regulations, human relations, okay? And in the end, I have to go through all of this so I have reliable and predictable outcomes, okay? And one of the things you find with the AI world is, hey, if I'm making a recommendation and I show you 10 things, 5 of which are right, it's still useful because you know how to pick them up, okay? If I have somebody who's critically ill and I get 10 recommendations and 5 of them are wrong, my friend over there is smiling, says, that's a different world, okay? Something else has to happen there. So I think I have that path to reliable outcomes that has to happen. And then the last one I bring up is sort of security, cybersecurity, privacy, and assurance. You know, I have to confess, I have a company in this space because you have 2 very difficult things. The first one is the data itself. Comes from many, many different sources. If I want to take a look at an individual, I have to tell you I'm part of something called the Digital Twin Consortium, okay? A lot of companies trying to build individual digital twins, okay? What you find is the sources of data for that, okay, come from all over the place. It's not just my EHR, okay? It's not what comes from the medical side. There are a lot of other things that affect what the outcome will be for a person, essentially, okay? And then I have the computing infrastructure, again, from everything that's embedded and local to hyperscaler and AI factories, very complex. This is true of both the computing, the data storage, I would say the science that's done behind all of this. And all of this has to lead to actionable and reliable outcomes. Okay? So the heart of all of this is the ability to share data, okay? And to do that in a responsible way, essentially. Before I go to questions, let me just say that if I look at this sort of for healthcare writ large, there are a lot of very positive things. But you really have to think of it the following way, and I think this sort of follows that Amara's law curve, okay? The first one is we do things that are diagnostics. Diagnostic, you know, what's the problem? We then try to figure out how to sort of climb the curve and sort of do a little bit of a prognostication. If you do this, you'll get better. If you don't do this, you're gonna get worse, okay? We then try to go to a level where there's some automation in the way this is done, okay? And eventually, sort of 5 levels up, you know, sort of autonomy where we have systems that we can actually trust with what's there. This is a long-term journey, okay? And my feeling is we're looking at incredible progress over the next 20, 25 years or so, where you'll actually see the fruits of what's being done. Lots of challenges, but also incredible opportunities. Okay, that's it. Thank you. Okay.
So do we have questions for Adam before I move? Oh, yeah. So I'll,
See slides.
yes.
So,
So Miguel asked us to be controversial, right? And so
okay.
I do some work. Well, my name is Paolo Bonato, right?
Gonna switch.
Sure, yeah. Oop.
Uh,
Oh, yeah, because just this here.
Get this a switch. You can,
Don't show this. Okay, don't show.
yeah. Just place that in. Swap.
Duplicate. Yeah,
Yep.
there you go.
Okay. So Miguel is guilty, right? Because he said, you know, that he wants us to be controversial, right? So And there is a tradition. So I do a bit of work with the Movement Disorder Society. If you guys are interested in Parkinson's or dystonia, right? You're probably familiar with the professional society. And in the tradition of the Movement Disorder Society, one night during the conference, two of the big shots that are actually really, really good friends, right? And so they're asked to take two opposite positions, right? And they just play the game, right? And so they don't necessarily think A versus B, right? And so they don't think, oh, you know, I need to use, I have to get patients on L-DOPA, carbidopa, or I need to use dopamine agonist, right? And so, but are actually asked to take that position, just as a game, right? And so what I'm going to do is I'm going to do the same. You can only do that if you are among friends, right? Because you have to be careful not to offend people. So I'm hoping that I'm not going to offend anybody. But what I'm going to try to demonstrate is that Miguel is wrong, right? So that's the game, right? And so, and I had some slides. Yeah, exactly, right. And so this is going to be a game, right? And I brought some slides. I wasn't sure exactly. Am I going to use it? Am I not going to use it? Right? And so, but as Miguel and Adam were talking, I said, yes, I'll do it, right? And I want to make 2 points. And for one, I have the slides. For the other one, I don't. But I think it's pretty obvious what I'm going to try to say. So the first point that I'm trying to do, that's my first counter, right, is that the problem that Michael Condrey, right, put forward, right, is a general framework. But the reality is that when we want to resolve a problem, we have to focus on the problem first. And so the generic statement, right, that AI is not transforming the way we develop technology for medical application, right? It has to be put in the context of a specific clinical applications. And I would argue that already we have seen very significant transformations in the field. And I'm going to provide an example on the basis of work that we do at Spalding Rehabilitation Hospital. That's where I work. I was trained as a biomedical engineer. At some point, I really wanted to work on translational research. And I just had the opportunity in a very serendipitous way. The chair of the Department of Physical Medicine and Rehabilitation at our medical school was really convinced that he needed to have an engineer in his department. And I was looking around. I was at Boston University back then. It's a great university, but there were a lot of senior people right in front of me. And I'm like, okay, let's just interview out there. And I just had an interview with this department chair, Walter Frontera, and I decided on the spot, this is my place. So I really want to give it a shot, right? And so, okay. And so I've been doing this since 2002. Right, so I've been there for 24 years, and this is the type of work that we do, right? And we really start from the problem, right? And the problem that we have, for instance, our stroke unit, is that when we look at the recovery of these patients, and for instance, we use some of the work done by Dutch colleagues in the Netherlands that studied this very extensively, right? And so we put on the x-axis time, right? So those are weeks, right? So you're looking into approximately 6 months post-stroke. And you're looking on the vertical axis at a clinical scale that captures the recovery of motor functions. Patients are very different in their presentation in the acute phase. And so this group, for instance, proposed to cluster them in 5 different clusters. And then they look into whether they can actually predict and, of course, positively affect their recovery. And what you notice right away is even when you look at a single cluster by color, right? And so the clusters, of course, are represented by colors. The variability is humongous. So it's very difficult for you to predict what you should do on a patient-by-patient basis on the basis of what you expect to be the outcomes of your intervention, right? And then if you have to revise the intervention, you would need to have that reference. So you need to have the ability to perform this prediction. So we started doing this work a while back, right? And so we published our first major paper in the Proceedings of the IEEE in 2010. And we said, you know, what if we look into upper limb functions, right? We strap IMUs on the wrists of those individuals and can, through traditional methods back then, right? So in 2010, we used random forests, right? We used the data feature engineering, and then we noticed that we had major issues using other techniques because they were not as robust as what we needed to the relatively small sample size that we had. And so we work with Jennifer D, that those of you who do machine learning might be familiar with. She does really fantastic work in this area. And she said, you know, why don't you give it a shot with a random forest? And can we derive then on that basis, can we derive proxy measures of functional impairments in these individuals so that we can build predictive algorithms, right? And so fast forward to 2020, we continued the work over a long period of time. We published in MPJ Digital Medicine a paper in which we show what engineers always like, which is plots that show a linear relationship between the, what you have on the horizontal axis, which are the clinical scores as obtained via assessment by physicians, and on the vertical axis, the estimates that we derive by using the sensing technology. Right? And why is this important? It's important because we want to address the variability in the recovery trajectories of these individuals, and we want to be able to adjust interventions accordingly. So let's assume that we're looking into a period of about 36 weeks. It's approximately the same time scale that you saw in the previous plots, right? So, and let's assume that we monitor a patient over the first 18 weeks. And let's assume that the clinical team decides that they want to use a pharmacotherapy to enhance the recovery of these individuals, right? Good. The problem is that, unfortunately, the clinical team doesn't really have good criteria to decide if the patient has to be on drug A versus drug B. If you have any interest for stroke, for instance, you know, and you talk to stroke specialists, they will say, oh, you know, in a subset of patients, we have good results with SSRI, right? So you basically plug into serotonergic pathways, right? And so in other patients, we really need to boost dopamine. And so in other patients, we're actually going to use Cinemet, which is a pharmacotherapy that you use, a drug that you use in Parkinson's as an off-label use to actually boost response in these individuals. But we don't really have good criteria baseline to figure out if a patient should be on SSRI, which we're probably going to put on if he has depression, but are we going to get good results on the motor point of view, right, on their motor recovery or not? We really don't have good criteria to decide if Mr. Smith is going to be on an SSRI or a dopamine replacement drug. So why don't we monitor them over time? We look at their recovery trajectory. We compare that with initial plots that I showed you earlier, right? And we say, within this cluster, are we optimizing the recovery of these individuals or we're not? And so in the plot here, we show in orange the estimates that we derive using the sensing technology. There are many in the room that do computer science, so you can easily imagine you can build predictive algorithms that are going to project and generate the green dots that are actually predictions of where the patient will end up at week 36 on the basis of your time series, right, over the first 18 weeks. And then if the clinical team decides, yeah, that's not where we need to be, then they do have now a tool in order to be able to decide that they want to switch the pharmacotherapy accordingly, right? So this is actually happening in the clinic, right? And so back to the initial question that Michael Condry had, right? And so where do you do the processing, right? And so it's a function of the application. In this case, what we really need to do is to provide offline feedback to the clinical team. So it really doesn't matter if you are logging information or you're processing on the units. However, in other applications, right, let me go forward. We want to provide patients directly with feedback, right? And so that's another application of the same technology. Now we still have units that we strap around the wrist of these patients. But we do something that's similar to, if anybody is familiar with stroke, with something that's called constraint-induced movement therapy, which means that you ask patients essentially, or you force them, if necessary, to use their stroke-affected limb as much as possible. Right? And in the clinic, what you do something that's, I think, almost borderline from a psychological point of view. You put a mitt on the contralateral side, and you force the patient to actually do motor practice with their stroke-affected limb. And this is actually very, very effective, right? So it's almost traumatic, right? So because patients dislike to have to use their stroke-affected limb, let's face it, right? And in fact, they use all sorts of strategies to compensate for it, right? And so including, of course, performing tasks with the contralateral limb, right? But they should be discouraged because particularly in the first few months post-stroke, you do have the opportunity to modify their trajectory in amazing ways because of the way the physiology is actually responding to their stroke. Right? So now, if you need to provide feedback, it's now important that you actually process the data on the units. Right? And so we develop techniques that allow us to tell the patients also what type of movements they are performing. Because, for instance, if we want the patient to practice these movements, right? And so they are reaching for objects, they're manipulating them, etc. Right? And so it is key, right, that we don't count when they move passively. For instance, did I kill the sharing? Nobody likes to share, but I do in this case, right? It doesn't cost me anything. I'm just kidding. I apologize if I didn't share properly. Are we good online as well? Remote is good. Okay. So I was saying very briefly, right? And so in this case, we decided we want actually to count movements that are purposeful movements, separately, for instance, from the movements that are associated with walking. Right? And so in that case, it makes a lot more sense to say, we call them goal-directed movements. We want to have algorithms that we're actually implementing on the units, right? And this is something that we are deploying, right? And not only we're doing that with wrist units with some of the startups in the Boston area, but we're also doing on ring sensors that we developed with a company down in San Diego, right? And then we process and it's very challenging, of course, right? So because now we're looking into a very small sensor unit. Now we're looking into a minuscule battery, right? And these toys, they have to run at least for the day, right? And so, but if we didn't process the data on the units and derive the GDMs, right, then we wouldn't be actually able to provide feedback. Right? So it's really a function of the application. So that's my point number one. The point number two, it takes 2 seconds actually to make. Yeah. But let me just make point number two because it takes really 20 seconds. When I talk to our clinical folks and I talk about AI, the most obvious thing it is to them that the largest impact that AI has had so far in clinical practice is to generate clinical notes. And it's incredibly popular among physicians, and we have one here, to use DeepScribe, right? And this is LLMs, right? So this is generative, right? So algorithms, right? So they listen to your conversation with the physician and they actually generate clinical notes. And why does it work? That's my actual second point, right? So it works because it doesn't need to be perfect. And something that we do make as a mistake in engineering is that we want it perfect. And the physicians don't care because it has to be good at 90%. And if it's a good at 90%, then they go through the notes and they fix it. Thank you.
No, you're still here. I apologize for interrupting. Does anybody have their car parked out here? This is why the policeman is here. He's not here to arrest me. Is it your car out there? Would you please talk to the policeman here? Yeah. I think it has to be in the garage. Sorry. Okay.
So I was actually done. And I didn't drive, so it's not my car. So,
So let me.
was I controversial enough? No.
No, what I would like to do now is
Yes.
It has value, okay? And in fact, doesn't have to be perfect. There are other applications for which that's not true.
Yeah,
Okay.
absolutely.
Okay, and so, you know, in fact, working on plasticity in the brain, okay, which is, I think, what you guys are doing.
Yes.
Okay. If I remember, there was a time when people thought that there was none. Okay, so there's a breakthrough at many levels, but a lot of this can be done with analytical techniques that are not even AI-based, is the point also. Okay.
I agree 1000%. In fact, from the engineering point of view, right, it is the wrong thing to do to kill a fly with a cannon, right? And so the choice has to be appropriate given the problem at hand, right? And for some of the problem that we have, so if we look into generating clinical notes, right? So, I mean, there is no doubt that the tools that are available to us today are absolutely phenomenal compared to what I witnessed 30 years ago when I got my first job as a research assistant in a research center. There was no way to generate anything that was meaningful. So physicians, they couldn't care less about that, right? That was the era of expert system.
Okay. What does it take, okay, to actually get the procedure that you ended up with accepted on the payment systems, on the medical payment systems?
insurance.
For insurance, okay, and be accepted, and how long did that path take?
Okay. Yeah. So I have to get up because I'm too short, and so you see the screen if I don't get up, right? So Miguel asked us to be provocative, right? So I'll be provocative, right? So I'm always very skeptical when people point at problems, right? So it's good to be aware of it because you have to resolve it, right? So, but it's the same when we have conversations about aging, right? And it always presented as a huge problem. And I just look at the audience and say, and again, I'm just to try to be provocative, right? That's incredibly stupid, right? Because aging is actually fantastic. The alternative to it is to die. That's not a good alternative. Life is about alternatives, right? So I mean,
Progress is 1 year every decade in terms of average age. Yeah, of life expectancy.
yeah.
Terrific progress.
That is fantastic, right?
Yeah,
Now
absolutely.
we need to acknowledge with the aging
That there are other things that
you're going
happen.
to have more neurological conditions.
Yeah,
Nothing wrong with that.
Yeah.
Right? You just need to get yourself
well,
equipped to do that.
once human beings live past age 45, we discover all kinds of new things.
Which is fantastic, right? Now it's the same for regulatory, right? And so it is an issue, right? And so I mean, I'm in healthcare, so it would be stupid on my side to say, "Oh, that's not a big deal," right? And so, but it's also true that in clinical practice, and we have a physician there, right? And so what happens, right? The reality is that
Balance, okay, between acknowledging new knowledge, okay, and the practices you had in the past.
yeah, so it's a matter of cost benefit ratio, right? It's a matter of risk versus benefits, right?
For many, many.
It is also, right? So when it gets on the business side, when it gets on the medical side, is do I have the information that it's necessary for me to make a decision? And as the physician at the table would tell us, you have to make the decision at the point of care, right? This is not engineering. Medicine, it's not something that you can wait another 3 months and see if you're going to find a solution, right? And so whereas in engineering, you can say, no, I need to bring my team together and we have to reevaluate and we're going to redesign and so on and so forth. In medicine, that's not a possibility. So what happens with wearable, right? So what happens is that in the clinic, it is common practice that physicians will ask, right? And so you have an arrhythmia, right? And so I'm subject to arrhythmias, right? So I went to my cardiologist. She's fantastic, right? So she knows that I'm in wearable, right? And so I didn't wear a proper device. She had to make a decision. Of course, I got them monitored properly, right? She asked me if I had my smartwatch data and my Oura Ring data, right? It is not, according to regulatory, right? So, but you work with what you have, right? So you have to be practical.
Yeah, I'm just mindful of these folks who have been patiently listening to this. And yeah, in keeping with the friendly kind of banter, I continue to maintain, in at least the physical hardware, physical device, physical wearable, that AI is nowhere ready for prime time. This is all well and good, and we agree in the concept. But I can tell you, in my business, we receive about 40 to 50 interested organizations of different size, from a Fortune 50 to, more often than not, startups and scale-ups. AI is not at this point in the physical side. I can't speak on the app software side. In the physical side, we're not there yet. And I found it very curious this week that, I don't know if any of you attended the Dell presentation by the COO of Dell. He deliberately did not talk about AI in the new generation of laptops, because customers don't want AI all over their machines. Taco Bell and Jack in the Box have gone away from Android robots taking your order when you drive through we have Ford and GM writing off billions because of electrical vehicle decision. That's a different conversation, but the technology is fascinating and intriguing and very exciting. But Zuckerberg spent billions on metaverse. Where's that? Apple spent billions on their headset. What is it called? Where is that? And so, yeah, in my practical world, in the physical, I want to continue to maintain physical medical device. AI is nowhere ready for prime time.
No, Miguel.
Yeah, if I could jump in here for a second, we actually do have some folks online, and they're throwing some questions in there too. So I think in the interest of having some interactivity, why don't open this up, Michael, here.
Yeah. So this goes to
Hold that closer to you, Mike.
Pablo's discussion is that how do you decide on the intent of movement versus what they're actually, and then enforce correct movement?
Yeah. So let me just say, just clearly, right? My job here was to be provocative enough to trigger a discussion here, and I think I was successful. So if the individual offline wants more details, but I'm more than happy to provide them just offline, right? And so, but if we're looking into movement intention, as opposed to the actual performance of movements, which is not necessarily of interest in the context that I explained earlier, then we use sensing technology that allows us to monitor that. And that's traditionally would be electromyographic data. So you essentially position electrodes on the belly of your muscles, and you capture the electrical field associated with the traveling the depolarized zones of muscle fibers, right? And so more recently, people, for instance, have done it by using ultrasound technology. There is a group at George Mason University that's very well known in this area, and they make it actually wearable, which is quite remarkable. And then there are groups that are actually looking into injecting magnetic beads into muscles when, for instance, you want to use them for the purpose of controlling prosthesis, right? So again, it gets to the point that it's really a function of the application that you're focused on.
Let me also here just for a second, if I might. There's some, oh, I'm sorry, Michael, did you want to say something? Go ahead. Yeah.
I can't really comment on the wearables for neuro rehabilitation, but I thought it was interesting some of the other comments that you were talking about for arrhythmia detection and what is the role of AI on the provider standpoint, because the provider and the patient want different things. Provider is both want best care for the patient, but the provider also wants really good workflow. They don't want to be burdened with paperwork. So that's why ambient scribes are so popular. That's one of the few places where that has gotten so much traction in AI in healthcare. The other one is revenue cycle management, which is also LLM based to see how much money you can churn out of that chart to make sure you can bill appropriately. Of course, that triggers an AI war on the payer side as well, making sure they can counter those. Right. The piece of having more data is not always better in healthcare. And I think that you have had a really interesting experience. The first feature that came out as a software as a medical device from wearables is the ECG feature. It's a single lead ECG, really looking at whether your rhythm is regular or irregular, seeing if you can have just a binary classifier of AFib or not. And that, of course, is trained on a population that you need to have a certain class balance where you have AFib. And if you have that, you may have if you deploy it in all comers, now you have a reasonable positive predictive outcome, and including, but you still will have a number of false positives as well. And so if you deploy that in a full population, you're going to a lot of people who are going to bring in their rhythm strips to their doctors who are going to be inundated by this. And now it clogs up the clinic and you can't actually take the best care of the patients that you need to. It's different than if you are a patient with known AFib and then you can say, actually, I already have this condition. My pretest probability is higher. I just want to know, was I in fib or not? And you can check the tracing and you say, yes, okay, now I know your fib burden is higher. So it's how you deploy it and a little bit about how it's trained that matters. But the incentives and the interests for both the patient and the provider are a little bit different. And I think we're maybe moving to questions?
Yeah, that's what I'd like to do now is I've got some questions online, but I would like to know if anybody in the audience has something they would like to address to the panel.
Yeah. Yes. Come down and take the microphone.
You could give us a hard time. It's acceptable. We were discussing his device earlier. Yeah. Go ahead.
Okay, so I was following the conversation about the medical stuff.
Dan, get closer to the microphone. Okay.
Better?
Good. Yeah, the better.
Okay, so actually I was going to ask Mr. Miguel, because I'm tending to think a little bit more along the lines that he does. So he has a fan over here. Yay, okay. So I'll give you a real world example. My director came to me with some paper that someone had written, some scholarly person had written, and this person was asking, he was trying to sell this to our department and say, hey, because of you're going to have this problem with your equipment, you need to educate your engineers. I just happened to have a seminar to educate them, right? So my boss handed me this and said, look this over and tell me what you think, whether this guy is on the money or not. So I looked at it, I read it, had some oscilloscope waveforms of this particular thing he was looking at. And I read it, and my first reaction was, no, that doesn't make any sense. This is not what he's saying and what I see are two different things. And I took the images, I extracted them out, I put them in a chat GPT sort of thing. I had to write a prompt that was at least a page long to explain what, I had to give it all the basis, all the other things. It was excruciatingly detailed. And then I plugged this in. I said, what are the top 10 things that this waveform could have been caused by? How could it have been created? And they came up with the answer. And the first two are the first two that I said, that I was thinking myself, and did not agree with the other guys. And I put that whole paper in there. So the question that I'm asking, and so this is why I have a tendency to think that because I have to do the creative thinking, I have to sit there and go through, look at this, look at this, look at the next particular item, and then analyze it, and then tell me what the analysis is. Because the AI can go out and gather the information faster for me. It can put it in front of me, but it doesn't, in itself, it doesn't ask questions of itself. It doesn't create, there's no spark in there. So I'm wondering, when do you see intuition starting?
Excellent. Yeah, no, so let me do the following thing. I just went through this exercise this morning with one of my engineers. Okay. And what he had done is actually a long chat GPT session, okay, on a circuit design, as it turns out. Okay. I took one look at it. And the first thing is 3 or 4 questions says, how could this possibly even be an answer? Okay. And what he did is went back, okay, with a critical prompt over and over again, and in roughly an hour got a totally different answer, okay, out of the ChatGPT session, okay? And so in a lot of ways, when you start looking at what is in an LLM, how does it work, okay? You have roughly 50 free parameters that somebody sets, okay? There's an attention parameter. There is that whole learning curve of, what's what. And all you get is a series of projections without the human intuition that you exhibited, okay? And I think there has to be a major step before this is cured, okay? This is where we are right now, okay? You see a lot of terrific things, but the value comes in at a level where the answers don't have to be very perfect, okay? If you want to have a fully autonomous car, level 5, human life at stake, all of that, you're dealing with a very different class of problems.
Yeah.
You're looking for 5 nines reliability, okay? And we're nowhere close to that right now.
Okay, I'm going to jump in here just for a second. We have about 15 minutes left, and it's so easy to get down into deep dive and stuff, but I think we want to have an opportunity for people to have, kind of a couple other questions. So maybe we could kind of make it a little bit more of a lightning round, where a quick question and then a couple answers from each of the panel members, and we'll see if we can cover as much ground as we possibly can in 15 minutes.
Okay, so I think this is applicable to a few different people to answer. It seems to me that for radiology, for example, AI has been better than radiologists for maybe 2 decades, and yet radiologists still read x-rays and not AI. I'm going to be provocative. I think that's criminal. Lives have been lost because for some reason, these powerful Machiavellian organizations still maintain their stranglehold and won't use a better tool.
Remember, you're talking to some doctors.
I'm sure. Well, that's why I'm being provocative. Similarly, I think that today Waymos are safer than drivers. And yet there are people going around driving cars, and Waymo is, if a Waymo ever hits and kills a person, the lawsuits will be astronomical. It'll set things back by decade. And yet people hit and kill people at 10 times the rate. So I'm curious from these different perspectives, what do you think's going on here, and how can we, integrate AI in these socio-technical systems?
So I guess let's go down the line, whoever wants to take this first, but I'm going to try and see if we can move things through 15 minutes. So kind of a short answer and then.
No, it's a fantastic question. And everybody likes to take a pot shot at radiology, especially the ICU. So yes, AI has been fantastic at image classification for radiology. Hands down, that is very true. And I think there's been a very slow adoption curve for a lot of that, probably a little bit from professional societies being reluctant to adopt it, but also the medical legal aspect is really tough, because at the end of the day, you need to have somebody who's willing to put their name on that and say, I'm accountable for this outcome. It's not necessarily going to be X AI system has read this this chest X-ray or this head CT, and now we can still make medical decisions on it. Because even if it was going to be the radiologist reading, let's say, the chest X-ray looking for a pneumothorax, a collapsed lung, and the radiology AI may say it's a normal chest X-ray, and even though there could have been a pneumothorax, let's say, now the person who ordered the chest X-ray, who then has to go manage the patient, has to take accountability for that. And maybe they're not as good as a radiologist, or maybe they're not as good as the AI. But either way, there's a level of accountability and culpability that has to be accounted for. And I think that's been really driving the reluctance for things like image classifier AI in radiology. Liability. Pathology is very similar in the same way. But the other thing that I want to talk about is your other question about Waymo, I think is very, very interesting. So how do we start to get these systems out into the world to start to save lives? So there's a big piece in the New York Times about Waymo being so unbelievably safe that it's criminal to have drivers anymore. And and if that's the case, then why didn't we do this sooner?
Vegas.
Especially at Las Vegas. If we launched it half-baked a year ago, when there was maybe some still edge cases, then you would see massive pushback, and it would be even slower to adopt now. So there's certainly trade-offs, and you could probably peel back some more regulations, some more medical legal liability issues to try to move these things forward. But then there's always fear of backlash. And I worry that some of these walls that are starting to tear down between healthcare and wellness indications from the FDA from the past week, we'll see a huge inflooding of wellness adjacent diagnostics on wearables that will then start to have repercussions in the health system. And I worry that 5 years from now, even 2 years from now, we're going to see a lot of people who will then not trust their devices, that when it has been really planned to move things forward, will actually have the opposite approach. Again, provocative, maybe.
Yeah. Let me bring another question up from the web. This is sort of awkward, but it goes back to what I was talking about earlier when I said, we have to balance the cost of from the edge to the thing. So that was the question that came in from the Silicon Valley group, was that, how do you balance AI technology costs and affordability and he says effectiveness, but I think they mean specificity. Versus the company's primary focus on profit making and short-term recovery. How do we set the path to make that work? So we'll give this to Adam to answer.
Okay. So how many of you have read something called The Inventor's Dilemma by Clayton Christensen? The Innovator's Dilemma. Okay. So what I find is, I think Christensen actually nailed the phenomena, okay? Institutions have incentive systems internally, okay? And it is very, very hard to change those incentive systems, okay? Because somebody gets a bonus for selling something, okay? If their bonus is threatened, they will not go along with it. It's very simple transactional in some sense, okay? And what you have seen is organizations that die over time, okay? I led one, okay? I look at Bellcore essentially serving the baby bells. Everything was built around the PSTN, okay, the Public Service Telephone Network. Okay, when all of a sudden you do a transition to the internet as your system of communications, okay, it threatened their livelihood. Okay, the willingness to have people retrain and say, hey, we got to rebuild the business, essentially, very, very hard to do. Okay, that change comes from the outside. And in economic terms, there's something called the howling winds of change. Okay, that's what eventually happens. That there is competition, somebody comes along with it, puts enough into it, and all of a sudden the world changes.
So kind of following on with that thread we've just been discussing about I think it's on the barriers and challenges. Let me posit this question to the group. I'm not going to ask you what is the biggest challenge to overcome because they're all major ones. Let me ask you though to kind of predict the future. Is there one of them that is a really big deal that we think if we can overcome, it's going to open a watershed and stuff is going to come out? Is it? I mean, a bunch of stuff came up here. I forgot about security. Somebody mentioned that. There's comfort. Is there one thing that will kind of open the floodgates if that actually ends up happening?
Yeah. My short answer would be get rid of the lawyers.
Shakespeare said that, right? Yeah.
I would say this is the wild, wild west, and it's a gold rush, and we need some serious guardrails. If Grok was a human being, he'd be registering as a sex offender right now for all the, I don't know if you guys have followed what has been happening. You can ask Grok to put an 8-year-old girl in a bikini and it will do it just like that. If he was a human, he'll be registering as a sex offender. There are no guardrails right now. And so until we have that, society is not going to trust it. And certainly capitalistic organizations are not going to trust it.
Is that going to come from government?
So it needs to be, unfortunately, the government.
So let's do the following. So what is sort of interesting is the Europeans over the last couple of decades, okay, introduced what I'll call framework legislation. Okay? The first one of those was GDPR that dealt with privacy. And I can tell you, it affected businesses all over the world, essentially. Okay? The second one, which they passed, I think, a year ago and started building up the machinery for, is something called the AI Act. Okay? And what they mandated is that when you look at an application of AI, okay, its criticality matters, and the way the law will deal with it is dependent on that criticality. Okay, there's a lot of common sense to it. Okay, what they didn't do, okay, is actually put in how you go about enforcing that law. Okay,
but it's a start, right?
Okay, and I think they're in the process of sort of revisiting those set of issues. Okay, okay, but a very sensible thing is at the heart of it. Okay, and that is it's a risk-based approach. Okay, in a very sensible way. Okay, how can you put the machinery to enforce that? I think is very difficult. Okay, but the fact that there is a uniform law makes it a lot easier to practice stuff. Okay, we do not have that. In fact, we have sort of balkanization. Okay, and that is, I look at laws on IoT, I look at laws on AI. They are at a local level, a state level, a city level, almost nothing at the national level right now. Okay, and the law doesn't work well when that happens, and business is very well, sort of averse to situations where there isn't really good legal precedent.
Okay. Let me, again, given that we only have a few more minutes left and I want to kind of diversify the conversation a little bit, if I take advantage of this, looking out 3, 4, 5 years out from now, what is something that's likely to happen in terms of an application adoption of AI or some barrier to falling that's just going to completely and totally blow people away? It's completely new. It's not something anyone has thought about before. I mean, you know, we see large language models and natural language, but it's been evolutionary kind of up till now. Is there?
Very definitive steps and stuff happen.
Okay, but do you see something coming down the road? What do you see that maybe is going to really change the way people
Yeah.
think? And
So let me tell you what I see, and two things. If I look at deployment of LLMs, that's probably the fastest deployment deep into the population in roughly a year or so. Okay, I don't think we have ever faced anything like that. Okay. You now see the main players sort of turning the power of LLMs on themselves, okay? Because one of the most expensive things in putting an LLM together is actually labeling data and creating models that have some degree of causality. You know, it's very expensive, okay? I now see some methods, sort of iterative methods, okay, which accelerate how well you do that, okay? So if you were to look at it, there's an outfit called epoch.ai, okay? And what it has is a series of curves, they track this stuff, of the level of improvement, okay, in the accuracy of the AI models, okay? And I can tell you, it's remarkable. Everybody who's tried this iterative trick has made tremendous progress.
That's good.
Go ahead.
Thank you. I want to be quick. I'd like to also get Paulo's and Mike's point here. The most exciting AI and optimistic AI presentation I've been to was at Berkeley a couple of weeks ago, where somebody with tremendous reputation in this space said that the word cancer will be non-existent in 15 years, maybe 12. That is very, possibly him. That to me is very exciting. I think it's the health of the human body and the health of the planet. That's where I really am very excited.
With proactive medicine.
Right.
Proactive medicine is critical. Your turn.
I will take a contrarian view. Seems to be the theme of the evening. I know I don't disagree with some of the rates of progress that you guys are talking about in medical innovation. I think there's going to be a lot to look forward to there. I think that health disparities will probably get worse because despite the best LLMs, the best diagnostic engines, ChatGPT, or all of these things outperforming like acing all the medical tests, you still have people who don't have the money to fill the prescriptions, who are have chronic medical challenges that are socioeconomic in nature, and I don't think AI is going to be able to address that. So it's I think that there are some things that will be very exciting in the future, and I really hope that AI can help be leveraged to address some of these other issues where the incentives need to be better aligned.
We need to get Paulo on this one. I insist.
Oh, so I'll be brief, believe it or not. Yes,
what's exciting?
yeah.
What's exciting?
First thing, if I may, I'm hoping that IEEE can actually play an important role in this context. IEEE has been phenomenal in terms of standards. It's typically considered something incredibly boring from an engineering point of view, but it is incredibly useful and it has a very significant impact on the healthcare system. I'm hoping that we're going to see more empowerment of patients. I acknowledge the fact that that is going to be extremely challenging. In the healthcare system, when you look into improving access, it often ends up being we're going to provide services more efficiently so we can make more money. And creating incentives so that that doesn't happen, it is very challenging, but I'm hoping that that's what we're going to see in the short term. In the long term, I'm hoping that we're going to look at what's happening right now in AI, right, as the way we're actually looking at our first experiments with neural networks 30 years ago, right? And so my department chair came to my office a little while back and said, you know, we want to do something on AI for physicians. When did you publish your first paper on this, right? And I had to dig it out. 1995, multi-layer perceptron. And I was told, not add more than 2 hidden layers because otherwise it's not going to converge, right? But we had no linearities. We really didn't know. We didn't know what to do otherwise, right? And I'm hoping that we're going to look into what's happening right now, 20 years from now, and make the same consideration that I'm making about our multi-layer perceptrons of 20 years ago.
A year from now, and here our CES event that we're going to pull together. And you know, this has been very active. I hope that the audience here has enjoyed it, but we've actually run out of time with the university. So we're going to have to call it. Thank you all for coming. We've gotten more questions online, but we're going to have to deal with them later. So thank you all very much.
Thanks, guys.
Yeah, thank you a lot.
This is great. We have to have a chance for fun.
Nice business progress. But I was saying, maybe that they did is straight. Okay. We have a little answer for every part of this snapping and the deal. So I don't know where it is.
That was a good conversation. It's here
No,
to
no,
talk
no.
about.
Let me give.
So here's some of your fan club here. All right, yeah, I think you're part-time. This was my big job. My big job, yeah.
And
I mean, come around.
you know, you learn.
Thank you. Thank you, guys.
With the failure. When the first. It has in the book. That was times in the original.
Yeah, guys, we do have a little reception. Hope you can join us.
Yeah, sure. 8 gigabytes. There's no way.